Like the best robot in the world today is less valuable for its owner than like an average computer was in 1960.
All right. Hi, everyone. Let's start with intros. Stefan, would you introduce yourself?
Yep. I'm Stefan Seltz-Axmacher. I'm CEO and co-founder of Polymath Robotics and the lesser good co-host of Automated, another robotics podcast.
All right. Ilia, would you introduce yourself?
And I'm Ilia Baranov, co-founder and CTO here at Polymath, and I'm the silent straight man partner of the Automated podcast.
Nice. All right. Hell yeah. So tell me about Polymath. Let's do a quick overview. Stefan, you want to jump in?
Yeah, of course. So Polymath, basically what we've done is we've taken the kind of commodity, hard but unpurchasable point-to-point navigation stack that every robotics team has to build over and over and over again. And we've packaged it up as software that can be deployed across any off-highway robot. So we don't want to be a vertical robotics company. We don't even want to be the only autonomy organization in the world. What we really want to do is we want to take the parts of your robotic stack that you've probably built three to 18 times and make it so that you can just integrate ours instead of rebuilding your own.
Mm-hmm.
We're on tractors, bulldozers, weird AGVs for the DoD. As neat updates from the last time we were on the show, we're on more different types of robots than we have people on our team.
Ooh.
And we can do everything from all of the software for point-to-point navigation all the way down to ripping out individual modules like a certifiable safety layer or localization or obstacle detection or any one of those things that you don't want to build and isn't really core to your own program.
Mm-hmm. Hell yeah. Ilya, anything to add?
No, I mean, Stefan basically summarized it. It's been a journey to build the team out. I think we're overall doing well. Probably not as well as we'd love to do in our wildest dreams, but
I don't think that's physically possible in robotics.
Would you say it's not possible?
I don't think there's I don't think it's physically possible in robotics to do as well as your wildest dreams.
Yeah, I guess it's not like or any tech business, some crazy unicorn startup for this. But you guys are also, I mean, trying not to have a vertical, trying to be more software focused, where you integrate real well with hardware.
Yep.
It's like that to me from our last conversation. It's like, it seems like a super good like lifestyle startup in a way.
Yeah, it's definitely a nicer life than having to ship engineers to West Nowheresville on 5 hours notice to try to fix something. But essentially, I think that's really interesting about this market and kind of, I'll describe it more towards roboticists. But after my first robotics startup, I went and hung out with some SaaS companies, and I didn't realize how much easier their life was. And it's not just the lack of hardware. I feel like a lot of people in robotics are like, okay, cool, yes, this is harder than DocuSign, but I got to buy actuators, I got to buy sensors, there's regulatory stuff maybe. It's like, that's actually not the why SaaS is easier. SaaS is easier because most people don't have to build most of the stuff. And if you're building a website, you should not really be doing back-end stuff unless you're a back-end website. You should not really be innovating on collecting credit card payments. You should not really be innovating on 99% of the code base of that website or that online service. Almost everything should be glue code, at least until you're the millions of dollars of ARR. Whereas in robotics, there's features that you've built in your last company. There's features that some PhD just wrote their thesis about. There's features that some company just did a really cool marketing video showing off that they can do, which leads everyone else to think that it is as easy to say, make a humanoid walk up, grab a doorknob, twist it, and walk through the door and gently close the door behind them. When in reality, if you were starting with if I sent you a Unitree humanoid today, it would still be a decent amount of work to get even to the point where you could do that, even if the hardware was out of the problem. And that's because of kind of this lack of being able to take components from one robotics program to another. And that's kind of what we're hoping to partially solve.
Mm-hmm. Yeah, I totally agree with that. And that's why a lot of web dev stuff feels so much faster because you don't have to write everything.
Yeah.
There's really good libraries for thorny specific problems like payments or auth or things like this. Yeah.
Like,
so
like
I
basically
totally get, go ahead.
Or you just go the vibe coding route, which Stefan has been experimenting with
cool.
to get something
But
strung
there are funny
together.
results from it.
Oh yeah.
But yeah.
Like, but like, I mean, I think like, and that's the gap between where robotics actually is and like where the people outside of robotics think it is only kind of seeming to get bigger as time goes on, because people, when you look at a web app, when you look at a SaaS application, any feature that you see, you can assume is commodity and easily replicable. The more money has gone into robotics, the more features people have seen, and they've applied that same heuristic to it. And that's a really
very interesting
thing.
Yeah. So I agree with you. And I feel like it's hard. I mean, like seeing the Unitree robot do like a side flip and stuff. It's like, it's hard not to project a lot of competence onto that.
I saw an interesting headline. And honestly, I don't know if this was a headline or a Reddit post, but someone saying Unitree is a scam. I bought a Unitree and I can't do some function. And I don't know if some function is walk up to a door, grab a doorknob and walk on through. I don't know if some function is do a backflip. I don't know if some function is navigate an obstacle course. But they bought this thing thinking, I've seen a Unitree do a cartwheel. If I buy a Unitree, it can do a cartwheel. Because that's how everything else works. It's only us losers in robotics where you see a function happen, you're like, cool, I'll go buy a $40,000 robot, and if I do a really good 9 months of hard work, I can replicate that thing I just saw.
Sort of. Yeah, for sure. So with this, you're saying everybody else does this. I understand it because, or like the way I think of it, and I'd like to see, Ilia, your perspective, and then jump back to you, Stefan. But the way I understand it is that robotics is very early. We don't have standards yet. We still haven't understood all the hard problems. You have ROS, and ROS solves some of the hard problems, but there's still plenty of hard problems, especially in the like behavioral space, which is what you guys are doing. But how do you think of this? Do you think that's correct that it is because we're still early, or or it's just harder, or what do you think?
Yeah, we kind of go back and forth on this topic a lot. And if you really think about it, robots as in industrial manipulators go back to around the same time that heavy iron computers started popping up. You know, you had the original hydraulic arms in auto plants come up around the same time as computers are really getting going. But computers have accelerated so much faster and made so much a deeper an impact on society than robots. And it's a question of why, right? And in a lot of ways, I think a big job of computing and of UI is to squish the weirdness of the world into a very specific framework that the computer can deal with. So like a screen with this type of web browser, with this kind of data, whatever, right? And a lot of work was done on, here's a communication protocol like TCP, here's a standard for wiring, here's a standard for CPUs so that everybody can interprocess. Whereas robotics never really had that push. And so industrial arms made by one company were drastically different than industrial arms made by another company. And up until very recently, if you bought like a ABB arm and were an expert in installing them, you'd know next to nothing about installing a KUKA arm. Like basically you were useless. In fact, you had to unlearn a bunch of stuff because of the ways that they do things. And it's only really in the last, let's call it 10, 15, maybe 20 years that we've started to have this kind of standardization layer appear in robotics. If I had to guess, I think one is because you don't have this nice screen box you can put a lot of your interaction and code in, there wasn't a good way to standardize on physical interaction with the world. Like even just think of grippers, right? Like there's no good way to say this gripper will work in every single condition, because it's either too expensive or too fragile or not precise enough, right? There's always some trade-offs. Whereas something like monitors, like we've had monitor standards for the last 50 years, right? Like there's no magic there. And so I think it's taken time to get the fundamental tech energy efficient enough and complex enough and powerful enough to the point where we now have enough extra compute power to add on this kind of standardization layer. Because anytime you standardize something, anytime you abstract something, and we do that a lot, you inevitably pay a performance cost. Like when I was working at Amazon on the little Astro robot, I have a little Lego model of it right here. We had to squeeze every microwatt out of the CPU because it was a small CPU and we had to do a lot of complicated things. And so you just don't have the space to do a lot of affordances and abstraction layers and those kind of things. And now we're starting to, right? And I think, again, we're seeing a little bit of this race of end-to-end neural models, and we can talk about that in a second, kind of, again, being very custom in a sense of like, here's a camera input, here's a steering wheel output, and magic happens in the middle and you don't know what it is. Battling off against more flexible applications, which can then be transported from robot to robot.
Yeah, I agree with you. So where do you think it's going, Ilia? And then Stefan, I'd love to hear your thoughts too.
Yeah, good question. I think I still, looking at the history of technology and looking at the history of the internet and computers in particular, I think almost universally the most open source, most comprehensible standard wins, and the most flexible one wins in almost every case, right? So I think that a lot of the big end-to-end neural net models, which are starting to come out for machine learning, if they're open source and adjustable, that's a good first step. But I think, especially in robotics and this kind of idea of embodied AI, you can't, for example, take a Unitree demo flip and put it onto an Atlas robot and install sudo apt install Atlas kickflip and there you go, it goes. That doesn't exist, right? And I think that's hampering progress. So I think there's still going to be an underlying flexibility layer that we still have to build, and that's part of what Polymath does and other groups. In introspection, in communication, in configuration management, these are all things that computers have more or less solved and robots haven't. And so I think there's a lot of growth there. And then I think on top of that layer is these kind of big end-to-end models, which tend to be very specific per task or per robot or per environment.
Okay. Stefan, what do you think?
So looking at kind of the broader history, like Ilia did, but more from the business sense, early crappy computers, like 50s era, 70s era type of computers, could be a massive amount of hardware expense, but create really, really big savings and really, really big upside. Like a single piece of hardware could save you tens of millions of dollars. If that hardware is changing your supply chain or accounting for how you're spending money, and you're a company the size of IBM or GM or whatever. And so the ROI was pretty big and pretty early, and that put pretty easy pressure on hey, let's drive down compute costs. So not just GM can do this, but also companies who are only worth $10 billion, and now companies who are only worth $1 billion, and so on and so forth. Robotics has more problems than just build a compute. There's also batteries, there's also actuators, there's also sensing, there's that big long list of other things, and it is hard to come up with a robot that individually saves a company more than $5 million a year. The best robot in the world today is less valuable for its owner than an average computer was in 1960. Probably even in just non-inflation adjusted dollars. The math probably doesn't make sense. So the pressures have been phenomenally
non-inflation.
different. Yeah.
Okay.
Even if you don't include inflation, probably one of those IBM mainframes in 1960 probably cost $10 million, and for GM saved them $150 million. And there's no robot that is comparable.
We have a good example that we can come back to in the mining space.
So the initial pressure for robots to get better, just the math didn't make as much sense in the 60s and the 70s and the 80s and the 90s and even in the aughts. I think a really cool thing happened for robotics, which is that a bunch of people made a crap ton of money on software, on web apps, on microservices, on organizing databases of information to make them quickly retrievable. And many of those people thought, hey, I'm a cool tech person. I got money to burn. Obviously, a cool tech person should be working on robots.
Definitely.
And that poured money into things like the various self-driving car programs. And I think that led to a race, a series of races where people put so much money into this market that, you know, compute continued to get better and cheaper as it naturally did, but ruggedized compute became commodity. Sensor modalities got wider, more reliable, more usable, and they became cheaper and cheaper and cheaper as massive amounts of, frankly, dumb money got poured in. Because everyone assumed that like Moore's law would work just as quickly for self-driving as it did for, you know, microchips in the 90s. And we now are in a position where the components that you need for robotics have never been cheaper. There's been 10 to 15 years of press release propaganda about how robots are imminently going to be here. So my hunch would be there's been more measurable interest in robotics in the last 15 years than the last 100 years put together.
Probably.
And
way more.
For us, an interesting thing has kind of happened where everyone assumes there's more robots than there are. And everyone assumes there should be more purchasable than it is. So, you know, a big part of what Polymath's business is, frankly, is there's these big industrial companies who have said, hey, cool, if you can drive a car in San Francisco, I want to drive a vehicle in a Roomba-like pattern in a weird part of a mine, 80 hours a week, nonstop. Who do I have to write a check to make that happen?
It's like no one exists.
Yeah, and that's what we're doing at Polymath, functionally speaking, and that's the type of operations that we're doing. But I think like the components for robotics have gotten cheaper. The interest has gotten to a fever pitch. And now it's a matter not of like, let's argue about which theoretical technology might be the most exciting 10 years from now. I think we're actually now in a, how do we as a market build products that sees this like incredible intersection of conditions to make robots, frankly, a relevant industry at the global stage.
Yeah, I think one thing I'm curious about your perspective on, and then Ilia, I want to hear your mining example, but the also a thing that I see a lot is labor shortages across things, which I think is creating additional pressure on the factors you're describing now. So it's like it's hard to find labor, people are aging out.
There's actually,
what do you think of that?
There's so labor shortages became pretty popular to talk about, I think, like post-COVID. I think those of us in the white collar world realized that we desperately need the people in the blue collar world to do stuff for our little tip of the pyramid to be so pleasant. But in reality, the sorts of industries that we primarily serve, you know, ag, mining, quarries, oil and gas, all the logistics, railroads, all of them have been plagued by labor shortages for the last 50 years in like pretty structural big ways. So like kind of fundamentally thinking about manufacturing, SKU diversity is generally bad.
What is that? I don't know what that is.
Yeah, SKU like SKU, like individual types of products that you have. Like when the iPhone came out, there was initially, you know, it only worked with one radio network, and there was three battery sizes. Three memory sizes, and that was all your options, because that was a orders of magnitude cheaper supply chain to manage, orders of magnitude cheaper engineering process to manage. Lots and lots and lots of advantages of, we sell, you know, Henry Ford, you can have your car in any color you want as long as it's black and as long as it's Model T.
Love that.
Right? Yeah. In industries like mining, however, labor shortages are so acute that there's been like massive explosions of vehicle diversity. And like there are vehicles that do fundamentally different things. Like you can't replace an excavator with a bulldozer. You can't replace a bulldozer with a haul truck. Like those are different things.
Totally.
But what I mean is like Caterpillar sells something in the range of 150 to 250 different types of bulldozer. Different engine sizes, different blade sizes, different configurations. All of that means, and like in total, Caterpillar has something like 800 different varieties of vehicle.
That's crazy.
Yeah. Like GM, my hunch would be, has like 45.
Yeah. Wildly different.
Yes.
Order of magnitude different. Okay.
And what happens when you have all this diversity is every part becomes more bespoke, which means more expensive. What happens is every fleet ends up being more diverse, which means you have fewer interchangeable parts, which means there's parts that like are really hard to get.
Just to make sure I understand, the reason that it becomes more bespoke is it becomes more bespoke, more custom, to make it so that you have things that are more suited to the job so that you can maximize the people that there are because of the labor shortages. Is that correct?
I need to basically have the biggest bulldozer that I can fit in these particular operating conditions because I can never get more people. And my mine can have a slightly smaller maximum size bulldozer than yours can. So you have a different model than I do.
So how has that trend been changing over time? Has it been equally bad for the last, you said like 50 years or something we've known these labor shortages? Or has it gotten worse, or how is it?
It seems like there are only more OEMs entering these markets, selling only more different types of equipment.
So that implies it's getting worse and worse.
Yep. And like these,
because it's more and more bespoke.
And these models, if you're John Deere, you want to sell people a new tractor as quickly as possible. So the sale of replacement parts gets sunsetted fairly frequently. We know of organizations that are building in-house tractors because it has a meaningful difference to their bottom line to be able to amortize the vehicle frame for 20 years as opposed to 10.
Wow, that's wild.
And all of this is because lack of having people.
Yeah.
And when you have all of these weird things, like going back to like the parts that you can't replace, the ultra class haul trucks have these really gigantic, 3 or 4 meter in 3 to 5 meter in diameter tires that are $50,000 to $100,000 a pop. I have heard stories of publicly traded companies worth hundreds of billions of dollars buying spare tires from known criminals because it meant the vehicle got back to work weeks earlier than it would have.
Yeah. It's wild.
And that's because you have a weird special vehicle with a weird special part. If in fact you're just using a truck like you'd see on a highway, you could go to the local equivalent of Jiffy Lube and buy a replacement tire. The reason you can't do that is because you can't get enough people to drive enough trucks to do that in that size vehicle.
And so you think with robots, if robots are able to take over some of the labor, we can have more general robots and thus economies of scale kick in, cost comes down.
It kind of becomes what is the most efficient size for hauling material out of a mine? And efficient starts to look like, okay, where can we get the most cheapest spare parts?
For maintainability and things.
And that also in turn makes it easier to make these things electric.
Yeah.
There's also the spares consideration here where when you have a critical piece of equipment, this is common in farming a lot, is that your crop that you're growing is not only your crop, but you're in a geographic location where your neighbors are growing the same crop too. And your harvest season is all at the same time. So your demand on your harvesters is like 0.000 1,000% 0.000.
Because everyone's one widget is failing at the same time.
Makes sense.
Because everyone has peak demand at the same time.
Exactly. And so as a farmer, it's actually a smart investment not only have one $2 million harvester, but to have two $2 million harvesters just in case the first one breaks. And it's that size and that cost because your most expensive thing is your person driving it. So if you don't need that and you instead have 10 $100,000 ones, if one of them breaks.
Yeah, it doesn't matter. If one's out of commission, so what?
Yeah.
Yeah, this to me sounds a lot like what Electric Sheep is doing, where they have really small mowers as opposed to really big ones that were created by labor shortages because they wanted one person to maximize their surface area.
Yep.
Exactly. It's the same thing.
Go ahead.
I'll get back to that example. The size of this equipment and the labor issues also kind of caused this interesting story where we were talking to a mining group about deploying autonomy on some of their ultra-class haul trucks. And, we did the math on the business case of how much they'll save, their improved reliability, those kind of things. And it came up to some number, I forget what it is, but let's call it like
Mm-hmm.
$5 million a year, making up a number. They talked to us, and then they came back and they said, you know what, we're going to put this on pause because we did the math that if we just put a circuit in the thing to turn off the engine if it's idling, like an idler, same thing you'd have in a car, auto start, auto stop, we'll save $30 million a year of fuel. Because the drivers have been idling their vehicles, charging their phone, waiting
and enjoying
for
the
the
air
next job to
conditioning.
come in.
Yeah.
Yeah, and the air conditioning, of course. And so, you know, there's those kind of efficiencies where all of the size and complexity causes these weird distortions where you need this really heavy fuel for very specific large equipment that has to be shipped in parts and assembled on site and lives its entire life on site and it gets buried on site. Like all these kind of very, very weird, complicated things just to reduce the amount of people at the tip. So if you have a supply chain, you know, and DoD things have similar concerns, right? Your farthest deployed base or your farthest deployed mine has the same problem. Every nut and bolt that has to get there has to go through 3 stops to get there and getting more and more expensive every time. And so the more you can reduce the amount of people you have at your furthest point, the smaller your overall support pyramid gets. And so every one driver we can save, we're saving probably 10-ish people that are moving food around and providing lodgings and doing HR and refueling. And so, and we don't, you know, Stefan and I don't suspect that we'll get a fully autonomous as in no human beings. You know, there's now factories, for example, that are coming on that called lights out factories where literally the overhead lighting is off because no human steps foot in it. This is happening a lot in China, for example, for cell phone production. I think that's further along than what outdoor mining robotics is right now, where you still need a human to do maintenance and refueling and change the tires and fix the gears, you know, that got jammed, for example. All those things, you'll still need some level of human support, but every one person we can strip increases the value of the asset drastically.
Yeah,
the mine
it's
itself.
that pyramid that you were mentioning. That's a really good metaphor for it. Because like you raise the top a little bit and then the like there's a significant side added, which goes all the way down.
Yep.
Support people, need support people, like HR, all the things, and supplies, cost, complexity.
Yeah, some of these really far mines, you know, just to give you an idea, especially in Australia, are so far that not only are the people flown in the spare parts, but there's fuel flown in. Right, they fly in jet fuel to refuel the planes that are flying back out.
That's crazy,
right? Yeah, it's so like,
and they were like, "That's the cheapest way to do it. Like that's the most efficient thing we thought of."
Yes.
Wow.
Yes. Yeah, they're not stupid. Right?
No, of course not.
You don't run a multi-billion-dollar business by not being efficient, but it's
there's also like some interesting like game theory that this impacts, where if you're going to set up a mine that size, it has to be that size. Like you have to rip the whole piece of ground apart. Things that extend the life of the mine by 6 years, but might be less environmentally destructive, just don't cut it. Whereas if the labor becomes more fungible, if that stops being the stopping point, you can be a lot more strategic about where you go when.
And you can be more efficient generally on resources. Gold, for example, there's no, you know, people have this image of like a guy with a pickaxe knocking nuggets of gold off the wall, but that doesn't exist anymore, right? It's like the geologist has told us that there's 1 ounce per metric ton
we go find
of material here, or more like 0.1 ounce per metric ton.
Yep, and then process it.
So yeah, you don't find it. You just process metric ton after metric ton after metric ton, and you need a certain size for that again because of that pyramid. But maybe there's another site that is 2 ounces per metric ton, but it's only 50,000 ounces total. And so there's no point of building a site there because you'll exhaust it before you can ramp up. That all becomes more possible with more automation, with less labor.
Yeah, I think that's a very cool, I mean, that does seem like generally how technology diffuses. It's like it starts super expensive, very difficult, and then it becomes commoditized over time. And then you get like web apps where you have payments as a service and stuff like that is kind of the end of that.
Yeah, and I think for us, we're on this curve right now where we're trying to build kind of a standard. I hate to use the term operating system because it's a little bit overused. Everybody has their own OS, But like we're trying to build the basic autonomy layer and all the hardware abstraction to interface with your autonomous machine, such that then you can do it and go build the really fun apps. And then either the client themselves or other developers, like Stefan is a good example on fuel versus yield usage, which you can't do right now. But with autonomy,
a lot of what I often jokingly refer to as like MBA porn about autonomy is pretty far disconnected from point to point navigation. So like if the example Ilia was calling out is in a mine, you have a work face where you're getting material from, you have a processor where you need to dump the material. You could imagine that there's two routes in between them. One is faster but less fuel efficient. The other is slower but more fuel efficient.
Yeah. And so it's an optimization problem to see which is better.
Not today. In today, you just drive the way you drive. Whereas in a half day of work, a reasonable developer could code up language that says, based on the prevailing price of our ore, based on the prevailing price of fuel, we'll route vehicles accordingly. And like,
or even less than two routes. It's just like your engine has an efficiency point. And so if you drive 10% slower, and try getting an operator to drive 10% slower consistently, right? Like that's like no maliciousness. It's just as a human, you're not gonna be
and you'll
so
be impatient
perfect
too.
Fuel price is higher, 10% lower. Fuel price is lower.
It's like I just want to get it done.
Like even that speed adjustment, is not possible. Whereas if you have an autonomy layer and you have a simple way to command it, that becomes basically trivial. Like that MBA could vibe code it with ChatGPT with 10 lines of code, basically, of like, look up fuel price, look up oil price or ore price, subtract, set the speed, send it to
see which is
API.
lower, pick one.
And I think like our kind of thesis right now about like what's going on in the world, there's a lot of attention being sucked up by humanoids, by foundation models for robots. None of that matters compared to what we just talked about. Like a fuel optimization, like what I just described, for a company like BHP, which is a $280 billion publicly traded mining company, that might individually give them $5 to $15 billion more profit a year. Like,
wow.
Like,
did you say billion?
Yes.
What?
Yeah. Like humanoids don't matter. Like it's just not like it's cool. It's neat, but
well. Asterisk. If BHP wants to increase their share price by being a tech forward company, I'm sure they'll buy one of every humanoid, make them dance a little bit, have their stock price raise, and that'll be enough. But the actual main drivers are
like we're in a state now where like for industry, the things that unlock that sort of efficiency hacking is now relatively trivial. Is now like pretty straightforward, where you could really just have a bunch of product manager types of people vibe code out solutions that drive very, very large gains in efficiency.
I am unsure if this is terrifying or what, but that's crazy. I see what you're saying. What a thing.
Yeah.
So, but it's really interesting to put robotics in this context, or a lot of robotics applications, that they are creating not that much for savings, whereas these efficiency gains might be hugely impactful, especially for these large companies.
Yep.
That's wild.
But you need the first,
because the robotics give you the monitoring and the ability to actuate it.
And that's the hill that a lot of robotics companies, in the control.
Oh.
Yeah. So again, another example, by the way, in agriculture is like 5-ish, 10-ish years ago, there's a ton of like ag data providers. We'll fly Quadrotor around and we'll give you data on the yield.
And they didn't do well.
That was super popular. And it was great until it hit the barrier of like, okay, but I have the data, now what do I do? Like, okay, I know that this particular point on the field is getting overwatered. What do you want me to do about it? Right? And so you need to actually close the loop with a system that actually take that data into account and actually change your behavior of your planting, your watering, or whatever. And so the same thing.
It's like quantified self stuff where you're just measuring, but you're not changing stuff.
but you're not
you
changing
need to close the
anything,
loop,
right?
as you're saying.
And so again, like you need intelligent actors. And so again, this is kind of like AI agents is the buzzword, but basically it's like you need drivers in seats of devices that are responded to data enough that they can do 100 adjustments per minute of their speed or their watering or their planting or whatever, which humans just can't do. And that's the piece to unlock it.
So we're working with a pretty large ag conglomerate that, you know, is large and secretive, and if I named them, you wouldn't recognize them. But yet I still shouldn't name them. They harvest a specialty crop, and they have, you know, a window of time, 3 to 6 months, to get all of it off the field. And every year they do not know whether they have 3 months or, you know, 5.5. They don't know that on January 1st. It depends on how rain happens in the first part, like in the growing season. Depends
Probably
on
changes during that time.
Changes on a daily basis.
Changes by geography.
So you want to estimate, basically, and you want to do the intelligent thing based on how likely it is that you have to get it out quicker versus
I mean, they're a super cool company and super data driven, do a lot of really neat analysis stuff. But like, as the season happens, they'll start to get a sense for how long it's going to be until crops start rotting in field. And we'll make decisions on the fly about, like, we're going to speed all of our harvesters up by 25%, or we're going to drop them by 10%, or we're going to do this, or we're going to do that, because that has very substantial yield impacts. They also like have to jump from one field to another, because while they have hundreds of thousands of acres under cultivation, those hundreds of thousands aren't all next to each other.
All over. Yeah.
So there's this kind of big, you know, traveling salesman, multi-level optimization game that they have to play. And like, some part of that is yell at guys on the phone with limited language to change their operations in real time. And that is a thing that robots can very quickly do. And like, we think it is reasonable to think that could lead to 10 to 20% more crops successfully getting off the field. And also, like, even like down to the minute where that equipment might be in a field and it might leave that field before the field is fully harvested, because they have to go to another field. But if you took in the data of the truck that's going to move that equipment from one field to another, and you took in that location to do a live estimated time of arrival, you could theoretically be operating until just the moment that truck arrives. You could change the road that you harvest to make you be as close as possible to where you're going to get loaded into that truck when it arrives, because that itself might mean they get 2 to 5% more product off the field.
Which makes a huge impact in terms of total sales. If
your fixed costs are the same, but you suddenly increase revenue by 4% through some data science shenanigans, that's the ball game.
Yeah, that's your entire profit margin, basically.
That's wild.
Or it's doubling your entire profit margin. Yeah.
It's such an interesting way to view everything, and it makes a lot of sense to me. And yeah, so there's tons of these big companies, and these big companies have very large inefficiencies. And it's partially just because people are in the loop, and people are not, you can't control people that well. Robotics has covered, like the quad rotor stuff you were mentioning, where they do a bunch of sensing. It's like, okay, sensing is not the only thing you need, because I remember this huge wave of quad rotor companies that had monitoring, and they almost entirely have gone out of business. And I think that is exactly why what you're saying, which is they couldn't change anything easily. And so this kind of thing, when you add robots and the robots make it possible to identify these things you can make better, and then to quickly put in practice whatever is best. That's incredible.
Yeah, I mean, like, this ag group does like studies on how much more efficiently they can harvest a field if they eliminate left turns. But humans will still do like left
UPS
turns.
Or something.
Like, but like if you're UPS and you want to try that out, you need a lot of data before you can slowly roll it out. And then there's a lot of change management to get rid of left turns. Whereas if you like we, for example, we're bidding on a program I think this is obscure enough and I'm not and unspecific enough that it's fine to talk pretty openly about. So we're bidding on a program to automate a vehicle in an asphalt lab. And basically they put asphalt outside in a ring, and drive a truck with a bunch of weight over it. This particular
they look
lab,
at tire wear, or what do they do?
think primarily wear on the asphalt.
The road wear.
Oh, on the asphalt.
Yep.
That's freaking hilarious to just make a circle of asphalt and then drive on it until
There's a truck that's been driving on this circle.
Variable.
Yep, the people are variable. There's a truck that's been driving on this lab 40 hours a week for the last 40 years. Right? But like if you want to set up an experiment in that lab, you need to write a test plan that says, okay, for the next 6 months, I want you to drive at 45 miles an hour and do a hard braking event every 15 minutes or something. And then you need to coach the person to actually do that. Whereas if that vehicle is suddenly autonomous, you could operate that testing environment like you would medical testing equipment, where you could be driving 24/7. Oh, there's a blizzard going on and you wouldn't want, no human should risk their life driving in an asphalt lab during a blizzard, I think is a easily agreeable statement.
Okay.
But like you could have the vehicle do erratic braking in a blizzard nonstop. You could have I could be running one experiment where I get every raining day of the year, and you could be doing a different naturalistic experiment where we're driving differently during daylight hours for Audro's experiment, and maybe Ilia is doing yet a different experiment about how long it takes for there to be a change in the coefficient of friction after it's finished raining and it's starting to dry out. And like those three tests can very much be run in parallel. Those three tests can very much be orchestrated by a piece of software. They can't be orchestrated by a person yelling at a truck driver.
Yeah, very interesting. Yeah, because I mean, basically what I'm imagining is you can tell a truck driver, you can tell a person to do these kinds of things, but the thing is the compliance will be somewhat low.
Yeah.
And you'll see a lot of noise introduced because of that. Whereas you can have the robot just follow it, and then you can more easily, it's like the standard deviation of different outcomes you see decreases. It becomes much pointier, much smaller distribution, or much narrower distribution.
Yep.
Okay. That's super cool. I love the idea of being able to command tests like that, so you can test. And you can also, especially if it's trivial to set up the tests, you can run more of them. So you get more data points, you understand more things, and then you can optimize more significantly.
Part of why I felt comfortable saying, what we're bidding for is because, to my knowledge, there's like 100 of these labs in America. Like I probably didn't say nearly anything that could lead you to guess where we're even bidding that for.
Well, we know it's not in Florida because of the blizzards.
But like there's in Florida, for example, I think there's at least 4 or 5 of these sorts of facilities where it's a test track for testing, blah, blah, blah. You don't need as many of them if you can get 150 hours a week of testing as opposed to 35 to 40.
For sure.
But I think coming back to the meta point though, like I think the through line here of what we're doing is a lot of what I would kind of, in quotation marks, but basic autonomy of moving a vehicle from A to B safely and successfully, and doing so in a way that makes business sense. And that seems boring in a lot of ways. Like all of that to most people we talk to, they're like, yeah, of course, like Waymo does it. Like why, how hard is it to do it in a space? Or, the DARPA Grand Challenge did it 10 years ago. What's the problem? And it's similar kind of discussion to, one computer ran once. Like there is a DoD computer in the 70s that could run a simulation and job's
we
done.
Solved it, nailed it, move on.
I think, yeah, exactly. Right. So there's this kind of trickle down effect.
I played Grand Theft Auto once. Why can't the Matrix be real?
yeah, exactly. That's a similar discussion, right? So I think to your point that you asked at the start of the thing, I think there's a lot of effort and hype right now in AI and humanoids and those sort of things. But I think if you look back on history, the lag between that being interesting and that being a significant chunk of the market is much bigger than people think, almost always, right? Like the lag between, smartphones appearing as a concept and smartphones being common, which was one of the fastest ever, was still like 6 years.
That's
I'd have
pretty
to guess,
fast
7
for everything.
Right. But tell that to a VC. Like that's the fastest tech ever, right? Here's my humanoid, which costs $30,000 to $120,000. The lag you're going to have from this to in every home is probably in the order of 12 to 20 years. So please invest $1 billion a year for the next 20 years, and maybe we'll be one of the winners. Versus kind of, Stefan and I have taken a much more cash efficient approach of like, where is the most expensive pain points that we can automate for the most amount of money with the least amount of technical effort and risk? Not because we're lazy, but because like, that's how you actually run an efficient business.
I view it as like, why do you need to make life harder?
Yeah.
Just do the valuable thing. Like you don't need to play life on hard mode. It's already difficult.
Especially when your life is with robots.
Yes, totally.
Yeah.
Let's see. Yeah. Ilia, I really like your point with all that. I wonder, let's see. I guess, so with all of this, what I think is a lot of times people focus on the real sexy applications and things like this, or the sexy demos. But I've been believing increasingly that the majority of the value is in really unsexy tasks that people don't get as excited for. But the thing is, it's like, but that's where you can make the biggest gains for these kinds of things and like start to realize the promise of robotics, say.
And I think there's a challenge right now because in a way you can think about there being like two different robotics markets. There's companies that I think of as like hype robotics, where the company exists because they're doing cool stuff. They get money because the thought is they could do more cool stuff. Eventually, cool stuff has to be valuable, right? So if we wait long enough, it will eventually do something. And then there's a
thought, anyways.
It's a thought. It's a thesis. And then there's companies who are building, robotics companies similar to how you would build a web app business or a SaaS company or an e-commerce site, where it's here's a problem that the market has that I can reasonably build a solution for with a seed round. And now that I built a solution for them, I can get them to pay enough money that there's a line of sight to where I take in more money every year than I spend. And there's and I'm not just talking my own book here. There's a couple companies in the solar market doing that. There's Burrow is a great example of that in ag. There's a bunch of that stuff, and I think that's taken me a while to realize is that jumping from hype over to realistic is like fraught with peril, and I don't know of many robotics companies
ones that have successfully made it.
Yeah, because like if you're worth $10 billion off of hype, like Cruise, for example, I think at peak was worth $30 billion from hype. But when no one was willing to say they're now worth $40 billion, all they had to fall back on was a robotaxi business that was maybe making $4 million a year.
Yeah,
and
super low.
That $4 million a year or that $1 million a year was never going to cover their 3,000 engineers
and huge burn rate,
$500 million a quarter burn or whatever.
What do you think of like Waymo with this? Because they're still around.
Yeah,
and I hear people like them quite a bit, and I think
Waymo's really cool.
Google funded.
I'm really rooting for it. But let me put you in a scenario, right? You are the CFO of Alphabet, right? You have an equity plan with 1% or so of Alphabet. So I haven't looked at. I don't like follow public companies that closely, but I think they're worth $1 trillion-ish, maybe $2. So 1% means
$1 trillion easy.
$10-ish billion of an equity incentive plan. If the hype around robotaxis is up and down, but let's say some bad thing happens to Waymo, some public bad thing happens, and that brings down Waymo stock 5%, even if it's just 5% for a month. So that means a loss of $50 billion in value. And it's right around the time when you're being asked to write another $5 to $10 billion check for Waymo.
Mm-hmm. Yeah, you just saw a 50 billion slide, and you're like,
even more than that,
this kind of thing.
If you, Audro, CFO of Alphabet, take that moment to decide, I'm going to cut Waymo. We're going to publicly announce it. The stock's going to bounce back to 5% and go up another 10%. The company Alphabet will suddenly be worth $150 billion more. And I, as Audro,
and responsible,
No, not even that. Screw your responsibility. Screw how cool you are. You, as Audro, will make an extra $1.5 billion.
Yeah.
would Audro, would you keep Waymo alive for as cool as it is and how impactful it could be and how many lives it could save for $1.5 billion? Could I pay you $1.5 billion to pull a plug?
I see how the incentives go. Yeah. That's crazy. Yeah, it makes sense.
And I think it's an amazing product. I think it's really cool technology. I really hope the situation I just described never comes to a pass. But I have yet to play that game
makes clear sense
with anyone
this kind of thing
who would keep it personally alive for what if I offered them $1.5 billion to be the person who signed a piece of paper to do less work.
To axe it. Yeah, I know, to do less work.
Yeah.
That's wild.
Yeah.
What a thing.
Yeah. So I really hope that I'm wrong. I really hope it's alive. But I think the challenge with these like hype programs and the challenge with these like big companies is they look incredibly stable from the outside because very few people are in the rooms where like it's like, hey guys, it's not just that Audrey will make $1.5 billion. Ilia will also make $1.5 billion, and Stefan, I'll make it easy $2.2 billion, and I can be pretty good with that situation.
Yeah, for sure.
And yeah, like we've seen, Ilia and I have been around for long enough to see a bunch of really good robotics companies with really cool tech die because of assholes in finance who can get a good bonus check. And that's just the scary reality, which means like the faster you can get to a self-sustaining robot, the more realistic it is to actually have robots.
Yeah. Yeah, it has to make sense financially, and it's very hard to jump that chasm from hype to practical for this kind of thing. Do you? I'm interested in both of your perspectives. Do you think any of the companies will make it out of the humanoid bubble? Like, will we see any winners from it, or will we? Will Tesla quietly chug away at it and solve it because they have the whole Tesla business, or what do you think? Maybe start with Ilia.
Like, I mean, I think you gotta define what you mean by winner, right? Like, is Boston Dynamics a winner because it eventually got traded around a bunch of times and ended up at Hyundai?
Say they make that, they jump across that chasm from hype to reality, where they are providing value that is justifying the cost of the business.
Well, I think Audrey, what you're really trying to say is they make more money. Will there be any company who makes more money selling humanoids than they spend as an organization?
Exactly.
Not like, because Ilia's retort was Boston Dynamics has made a bunch of money and a bunch of investors have made a bunch of money in Boston Dynamics without actually shipping robots at scale, which, to be fair, is a great trick that I'd love to be able to pull off.
Yeah.
Yeah. No, I mean, I don't know the internal numbers for something like Unitree, but they're one of the few who are seemingly shipping in volume at reasonable prices, and I doubt they're wildly profitable, but I also doubt that they're losing money on every Unitree robot they ship. Like they're probably, because the trick they also do is like, I don't remember exactly, don't quote me exactly, but like the humanoid robot, there's the $30,000
rises
model
significantly.
But then if you actually want to do anything with it, like the model that actually has sensors and compute is like 120, right? Like the 30,000 is a RC
and burns out when you look at it,
more or less,
kind of thing.
Right. Right. So I think if I had to guess, on the $30,000 model they're spending 28. And on the $120,000 model, they're spending 100 and like something, 110 maybe, right? So
low margins.
Maybe they're making money. Have they made back the money they invested in it? Probably not yet. But again, I just don't see Unitree as a company that's willing to just burn money for no reason. So they're probably the closest. I think all the other kind of startups are deep in the red, including Tesla or Optimus, right? Like those are all until your robot shows up on Robot Shop and you can swipe your credit card and buy now. Like I don't suspect that they're quite there yet.
Makes sense.
I have someone told me that they knew of someone doing this strategy, but I have a strategy that I think would work in the humanoids, which I think of as I call like the minimally viable humanoid. And to be clear, you have to be big enough to build 2 robots to pull out the strategy. So your first robot is your cool humanoid. And your cool humanoid has legs, it has hands, it has a head that looks like a head. Maybe there's a little bit of face LEDs. There's a bunch of sensors in it. There's a bunch of compute on board. It can do really, really cool stuff.
Yeah, it's the race car.
Yeah,
for sure.
Costs $3 million, but it's in every press release. The robot alongside of it is the minimally viable humanoid, which is on wheels, might even be tethered. Sure, there's probably a sensor cluster, but that sensor cluster isn't necessarily round. It's not necessarily in a head-shaped thing. It's kind of wherever the sensors should be. There might be 2 arms. There might only be 1. The arms might have fingers. They might have something that looks more like an gripper,
like a pincher.
Yeah. And it's probably, bill of materials is probably in the the $20,000 to $40,000 range. And the whole point of it is it is easily deployable in smaller, non-massive factories to do things like machine tending or depalletizing or getting things out of a box or into boxes, and can kind of rapidly be moved from one task to another with maybe only 2 hours of setup. And I think I've heard a company, I wanted to say 1X might be doing this, but
they went the other way. They went the other way. They built the wheeled one, and now they're building the full humanoid one.
Yeah, and I think that is a strategy where like people will show up to buy the cool looking one, and then when you're like, yep, the cool looking one is great, $2 million and has 20 minutes of runtime. The wheeled one will fit your application and is economical compared to a human. Buy one of the cool ones. We'd love you to buy one, but buy 50 of the wheeled ones.
I also think like on a meta level, the whole idea of humanoids sort of is sort of like a fallacy.
Why is that?
In my mind? I feel I'm probably making a wrong prediction here, but like, I looked at X1's recent video, like promo, and they're like, oh, 1X, thank you. And like the humanoid is moving a vacuum, like specifically a Dyson, of course, a Dyson around somebody's house. And they're like, we're going for home robots. Do you know what home robot vacuum cleaner most people have? It doesn't look anything like a humanoid. It costs 1/100th the price, and it works just great. I have 3 of them in my house, right? Right. And it's the whole like, we live in a world of horse-drawn carriages, and somebody's like, I'm going to make a more efficient horse-drawn carriage. It's going to be a mechanized horse instead of a car, right? Like, I think that's the fallacy people fall into. And there's this thing like, oh yeah, but the human world is built for humans. And like, yeah, sorta. Like, my house has stairs, but it also has perfectly flat floors.
I actually rarely interact with the part of the world that that was built for humans. And like, so to be clear,
what do you mean?
Yeah. Humans did not come about in houses with level floors and heating and protection from the elements and whatever. Humans came about in forests. Regardless of how you think we came about there, so as to not pick a particular side, but regardless of it, you need legs for walking in mud and sand and dirt, and arms for picking up. You're
saying it doesn't have to fit the same optimization.
Problem. I live.
The constraints that made us aren't what made that a robot needs.
I'm a city person who rarely leaves.
There's a reason wheels never involved.
My life is between a series of flat surfaces. Like my house is a series of flat surfaces. The stairs are some more flat surfaces. It's flat surfaces.
I feel like that is the most robotics way to put it.
Like I outside of my 10-minute walk between my house and our office, I am never more than 30 feet from an outlet. Ever. That's just not a thing in my life.
Yeah.
I'm never outside of cell phone range. I'm not a big hiker, but also I don't need to buy a $10,000 device to hike with. That's theoretically, if I'm hiking, I should not be like bringing a computer on legs.
And I think again, like the meta point is like, I think there'll be more robots in homes over time. And there are already, right? And the robot vacuum cleaner makers are making units with arms
to like move simple things.
The ability to climb stairs. Right. And like, and I think the home robots, again, the Astro being an example, but like a bunch of them, I don't think need to be human shaped to accomplish their task. And so I think humanoids are very cool looking, but I think it's a fallacy, honestly. I think it's a fallacy until technology progresses a few more orders of magnitude, and then maybe,
like triple clicking on this a little bit. And this is kind of a new thought, so this might sound really stupid. A humanoid, so general purpose is a cool general idea, and it makes a lot of sense if you can only have one thing, right? If you can only have one computer, it makes sense for that computer to be in your living room. It makes sense to have multiple user accounts so everyone in the family can log into it. It makes sense for it to have a bunch of central things. There's a bunch of things like that go along with that. And humanoids are significantly more expensive than the family computer was back in the 90s. What's happened since then, and I'm just looking around myself because I am an embarrassing person with what I'm about to talk about. We have infinite computers. We can have infinite, like looking around me, I have 2 smart speakers here. I have an Apple Watch on, another Apple Watch right there, a phone, a laptop here, another laptop over there, an Apple TV, which is functionally another computer right over there, a smart TV that can also stream things. And I'm just looking at like the thing. I have a Kindle sitting on my desk. This is one of like 4 Kindles I own. I have an iPad. I have all these things. I cannot imagine a world where a single $10,000 desktop computer would be better than the series of devices I just listed off as being within 8 feet of me. And similarly to Ilia's point about Roombas, for intelligent mechatronic devices that I might want in my household, it is hard for me to imagine a series of applications I'd want done by a robot that would add up to something I'd spend $5,000 to $10,000 on. But I can imagine buying 15 $200 robots one by one over the course of 6 years. Maybe buying one $5,000 robot that does all of my like 8 applications that I care about a robot doing. That's probably never going to happen. That's like probably a non-starter with my wife. Like maybe if something really cool happens and a massive amount of money comes my way, like maybe I can blow 10 grand on something like that.
It's just that. Yeah. It's blowing that money on it kind of thing because of the novelty.
Yeah. And I think again, like humans, and we fall into this too, by the way. We fall into this fallacy all the time. Stefan and I had a discussion probably a year ago now on our podcast where basically we were like, oh, I want the classic, like, go get me a beer from the fridge robot. And it was like, okay, so you need like a robot with an arm that goes and opens the fridge and like finds, manipulates, gets the beer, brings it back, whatever. And I was like, Stefan, or you like, and this wasn't in the house, by the way. This is for work, so it makes a little bit more sense, right?
Because we drink in the office, not
office facility.
Oh, well, very, very good to clear up.
Right. Yeah. But like, and he was like overcomplicated this whole thing. I was like, Stefan, you could just have a vending machine. Like a vending machine already has all the management and can deliver one at a time. Yeah. No. Hang on. My point is like, my point is like a Roomba or an Astro or whatever, like a robot I can summon somewhere, and a vending machine plus a ramp will do everything you want. Like, you drive the robot under the ramp, you internet call the vending machine because they're almost all internet connected now anyway. It dispenses the beer you want, it falls into the thing, and it delivers your slightly shaken beer to your room for a fraction of the cost of any arm or any manipulator or any sensing or any humanoid you could possibly buy. Right? Like, even cheaper than a Unitree robot. easily.
Our other version of this is because people always like the idea of robots for the dishwasher, for taking dishes out of the dishwasher. And I have exciting news for you, Audra. There's a robot you can buy that does this. And for any of the listeners, for $400, purchasable at nearly any big box store, buy a second dishwasher.
Yeah, totally.
Yeah. Suddenly, if you put all your dirty plates in one, take all your standard plates out of the clean one, just flop them back and forth, and look at that. I just saved you 95% of your dish putting away with technology.
And then you don't need space for storing them. Even better. Yeah. It's more efficient.
You already have space for storing your plates, so you just take one of your cabinets and turn it into another dishwasher.
Yeah.
I mean, that's a little
yeah,
crazy,
what's funny though
like,
is less crazy the main thing, than having a big piece of metal go around my house for $10,000.
Exactly.
And scare the bejesus out of my dog.
This 1X group, like, I think, again, looking at their press release recently, they're like, we're really targeting, like, we decided to target the home market. And I was like, why? There's no, I can't think of a reason other than you tried to go after the industrial market, realize that it doesn't make sense, and now have to pivot to get more funding and more hype. Because, like, in every other respect, the industrial market is so much more valuable and so much more forgiving of failures. Like, an industry that's testing a new technology will be okay if you drop a part. Somebody who's testing in their home and you drop a plate will put a negative review on Amazon instantly. Like, it with no hesitation.
Drop my plate.
Right? Like, there's no reason to go after that market unless you just can't. Yeah. Unless you just can't hack it.
I wonder, the thing that was interesting to me, I haven't been in touch with them in a while since I interned, really. I mean, I saw them a few other times since, but when I started with 1X as an intern, we were going after elder care for this kind of thing. And that application, it was like remote. Someone would beam into it and have it microwave food or something like this, which the prices of assisted living are very high. Yeah. So that made some sense to me. I liked the mission there, but then it was surprising to see them pivoting a few times. And maybe it is a funding thing. I don't know. But it is funny how much you can simplify things with better design than just throwing a very expensive robot at it. A parallel that I have from my experience is for the first year of this podcast, I was trying very heavily to use AI tools for helping me find clips, helping me do editing. Like Descript will, it'll pick the person to be in the shots and things like this. And so I was trying so hard to get AI tools to work for this. And then I got so frustrated with it that I just hired someone. And they're not that expensive. They're absolutely wonderful. And it's a huge, like, the quality is far, far higher, and it doesn't have like weird artifacts. Drastically better
for
this kind of thing. And similarly,
of course,
hiring, like, so you could buy a, say it goes down to $5,000 robots, or you could just hire a house cleaner for this kind of thing. And they'll be excellent in custom work and things like this.
There are services that are like Uber for people to show up at your parents' house to microwave food for them.
Yeah.
And those services are not that expensive. Like those services like approach like $10 a visit.
Wow. That's crazy.
And like maybe I'm rounding down too aggressively, but not $100.
Yeah.
The math for that being a better outcome than buying a humanoid is like pretty, not incredibly hard for that to work out. And I think like there's a hard thing in robotics that happens frequently is roboticists are a specialized skill set who generally don't want to go work on a SaaS app or Hot or Not for cats or whatever. So it's kind of like, I have robotics. Where can I put robots? With a little bit less thought to like, what is the best solution for the problem at hand? And I think like, I don't think any of us here are bearish on, is there value in robotics? I don't think any of us here think like AI tools are net negative, but like all three of us have gotten to play and use AI and machine learning and deep learning for like, I mean, I think at least a decade plus each. It's really cool, But like the word AI feels like a stretch.
Yeah.
and that almost makes us seem like the most negative people in the world about these incredibly cool technologies. I think like my view of broader AI is AI is going to be as big of a deal for over the next decade as like microservices were in the 2010s. And like there's a bunch of people for whom that's like, I don't know what microservice architecture is. I don't know what that is. Cool. And those are the people who are probably not making good AI investments right now.
Yeah, I think so.
Whereas instead, like, yeah, AI is going to make every company 10 to 20% efficient. Not 98% more efficient, but like 10 to 20. And 10 to 20 is pretty meaningful GDP lift. Yes, like massive, a huge deal, but not no one has a job anymore. And we don't need video editors anymore. And humanoids will do all physical labor for us in every situation.
Yeah.
Which is a bummer because it'd be cool.
Yeah. Go ahead, Ilia.
I want to wrench us in another direction. Just one funny comment, right?
Yeah, go ahead.
One challenge for your listeners and viewers is next time you do see a humanoid ad, check if they show how the thing charges and how long its battery life is. Because I think, and I could easily be wrong because I haven't seen every single one, but I think I haven't seen one yet that shows itself plugging itself in to recharge. And that is a trick that
1X does.
Huh?
I've seen a video of 1X's robots charging themselves.
Oh, awesome. Because that is a trick PR2 did a decade and a half.
Way back. Yeah.
Right. And so like for the full like usability cycle, how do you make sure that the thing can actually charge itself reliably? Because again, even your Roomba fails to dock.
I know, all the time.
Yeah. Yeah. Right. So anyway, I'll stop harping on that. But like, if you're getting the itch to buy a humanoid, check that fact. How long is the battery life and does it charge itself?
I think the battery life thing is a very interesting thing because they can plug themselves in to some level. 1X, it was the wheeled base one that I've seen. I haven't seen their bipedal one, but it's an interesting thing because the battery life might be super short. I don't know.
The bigger thing that I've yet to ever hear anyone be able to justify to me, even in passing, is why legs. I have yet to hear an argument for why legs.
Best one I've heard is stairs. Like for home use, stairs.
Yeah,
like that's
lots of stairs in the middle of my airplane factory. Or
factory. For industrial. Yeah, I get that. People are excited about home.
Yeah.
Well, yeah. Which is why computers first came to the home. Like the first place that anyone had a computer was in their living room.
To store recipes, right? Wasn't that they were
that was it.
Like store recipes.
Room size computer. You don't need a living room if you have a computer to print out cards with what your recipe is.
And but so just to be clear, just so we're not losing anyone, computers first went into businesses, right? For Excel and this kind of thing.
Yeah.
And then the applications came later as the costs drove down. So I suspect that that's probably the good metaphor, not starting with the home, as you're suggesting.
Yeah.
What do you, segueing a bit, what are you thinking about all the LLM stuff and vibe coding and things like this? Let's see. Stefan, you've been playing with it.
Yeah.
What were your impressions? I've done it a bit, and it's very good, but you can hang yourself in the complexity very quick.
Yeah.
If you don't structure things well.
So I'd say I'm probably 3 hours into playing around with it. So this is relatively light. The thing that I'm trying to do right now is have it vibe code an application that lives behind an email address. Like a back-end application.
Emails are hard. Okay.
But by the way, what's your definition, Stefan, of a vibe coding? Just so we're all on the same page.
I've been able to do Hello World and a little bit beyond that in Python and C++ before. So I'm trying to describe a function that needs to happen and it be coded for me. And the function I'm trying to get to is take a Zoom summary of a sales call, which is, let's say, 2,000 words long. Forward it to an email address that then runs it against ChatGPT to turn it into 5 bullets. So that after a call,
that's fairly straightforward. Yep. Oh yeah.
I've been using Windsurf. It will not compile. Will not turn on and has struggled to be able to adjust prompts. Is the status of my code base.
Cursor is actually pretty sophisticated for things. I would suspect you'd be able to be successful with that application in Cursor. You use a good model like I find Claude 3.5, 3.7 now to be the best model for these things. But I would think you'd be able to achieve that for sure.
And like, to be clear, I've my 3 hours is a series of 30-minute increments with, hey, go write a complex email to this person about a complex subject. So I've hardly been flow state developing, let alone flow state vibe developing.
That makes sense. Ilia, what do you think? Have you played around with it at all?
Yeah, I mean, for sure. I mean, that also, to Stefan's point, you're still probably in the top quartile of people who've touched software before and have some concept of compiling and, that sort of thing, which is like still a very small piece of the population. I think we got to step outside of our bubble and remember that, like, the vast majority of humanity has no idea how the magic in the box works to run software.
Most people that are not robotics people or like software people have not even tried ChatGPT yet that I've talked to, which is nuts. Like, you just talk to general people, they're like, I've heard about it, but I haven't tried it. Which is just unbelievable because it's been a year and a half or whatever.
Yeah, so you're already talking to like a person who, through experience, is in a very small slice of the population, right?
Definitely. And you too, especially. Yeah.
Well, yeah. And on my end, I code semi-regularly, usually to the chagrin of my engineering team whenever I have to do anything. And generally, I use it for 2 reasons. One is if I'm trying to put together any kind of complex documentation or email or something where I'm trying to get a very large thought across, the first thing I do, I've almost replaced mind mapping with prompting, where I'll be like, I want to write...
Almost, yeah.
Like, I want to write, unless it's very esoteric, right? Mm-hmm. But like, I want to write, object-oriented programming for robots. Like, that's the title of my talk, making one up, right? What should I consider? And it'll list out a bunch. And then I'll pick like 5 or 6. I'll be like, yeah, okay, that sounds interesting. I might go with that. Let's talk a bit more about that.
Great,
and that helps me build a skeleton, basically, or a mind map. And then from that, then I'm writing it myself and doing whatever, right?
Then you're back to your mind map. Yeah.
Right. And like that mind map phase, I could be sitting drinking coffee and just trying to think of ideas from thin air for like 30 minutes. Instead, it takes me 3, right? And like skips that phase, and then it sort of narrows my focus, and it will usually miss stuff that I do want to talk about. So I'm kind of hybridizing it with my own thoughts. But it saves me that 30 minutes. That's like half the usage of ChatGPT for me. The other half, or that kind of LLM, the other half, I was recently doing kind of like camera distortion and projection to get a top-down view from a camera. And that was like, what libraries exist and how do they behave and what's the easiest way?
Oh, hell yeah. That's
and
a great
it gave me
use.
some ideas, right? And it's like, here's an OpenCV function. It takes these as arguments. I'll go back, I'll try it out, I'll code it, I'll hit an error. I'll be like, okay, what the heck is this error? And that, again, it saves this iteration time a little bit. So it takes the initial development that usually takes, 45 minutes to 2 hours down to 10 minutes to half an hour.
Totally.
That's pretty valuable. I find it becomes less and less valuable taking from that to a final code of a complex piece of software. I agree. It breaks more and more and more and more to the point where it's useless. But the really early stuff, it speeds up quite a bit.
Yep. Yeah, I think like de-risking things technically very quickly, because you can get a prototype real fast, is fantastic. You can see which libraries work. You can run into things that weren't documented well. This super valuable in my experience. But yeah, it's an interesting world we're heading into with all of this.
I mean, I think like we've fooled around with some stuff. So our architecture basically has a common autonomy core nestled in between 2 hardware abstraction layers that sit between us and our given sensors for a vehicle, us and the actual drive-by-wire of a vehicle. And so the most effort, the most dev work for bringing up a new robot for us, or a new type of robot, is building that hardware abstraction layer, especially between us and the drive-by-wire. So we've looked at, hey, how can we use AI to get there? And we've seen some like early cool stuff. But my hunch is, I think in general, much of the work that we have to do is good software best practices more than it is like build AI to recognize a novel situation and categorize it into some archetypical situation that we have a known behavior for. Because like the types of vehicles that we're focusing on shouldn't be making judgment calls like that, even when they're human driven.
It's very procedural.
Yeah. Like I've seen procedure docs for sites where, they're driving a large wheel loader that is, say, 50 to 100,000 pounds. And the rules for operating that wheel loader are, if you're in reverse and you see someone standing within 100 meters behind you, turn off the engine, get on the radio, call for help. If you're driving from here to there and you notice that this gate is open, turn off the engine, get on the radio, call for help. If this beeper goes off, turn off the engine, get on the radio, call for help. These large kind of terrifying machines should not be judging pedestrian intent. It's kind of deterministic. If pedestrian, then stop moving.
That makes sense.
Yeah.
Yeah, what a funny thing that it makes sense. They follow the simple, and it probably increases how fast they can train people rather than handling all the appropriate conditions. And they need one well-trained person instead of every truck operator.
And I think like
kind of
things like that, a lot of these sites, things can go wrong with like when very simple rules are broken. So it's a rehashing constantly of simple, straightforward rules. And in part, they're simple because it's then easier for other people to notice if someone's not following the rules.
Oh, interesting. Well, let's see. So one thing that I wanted to make sure we talk about today. So I'm having a baby girl in about 6 weeks from when we're recording. You guys both have kids.
Yep.
I don't often hear this discussed with founders and this kind of thing. I'd love to hear your perspectives on how it is to have a family, but also you guys are doing your startup. Startup life is notorious for being chaotic and busy all the time and everything. I'd love to hear what you think about it and how your experience has been.
Yeah.
You want to start, Stefan?
Yeah. I've done a startup with no kids. I've done a startup with a kid. So it's good. It's a good middle ground.
Well informed.
Yeah. It is significantly harder. That is not a joke. I mean, I think there's an old Sam Altman quote from back when he was just a measly YC partner, not, the CEO of OpenAI. That was, when you're a startup founder, you get to have like one hobby. Like that hobby might be that you have friends. It might be that you like kite surfing. It might be that you go backpacking, but you get like one. And when I didn't have kids, my hobby was I had friends, and now my hobby largely is I have a kid. And that is where my free non-work, non-productive time goes. Which is, that is a trade-off, that is a thing, but that's kind of part of the deal. It helps that I'm, in my 30s and I did a bunch of fun social things in my 20s. I'm okay with like the change. There's a lot of parallels, I think. So I don't know if you guys have signed up for this, you and your partner. There's a great Montessori toy subscription called Love Every.
Okay.
Which highly recommend. My kid seems to be smart.
You got like 5 months until this starts becoming relevant, to be clear. The first 3 months, they're not going to be playing very much.
Fritz loved his like first 3 month toys. He
wow.
Yeah. Like, I mean, a lot of them were like black and white cards with patterns on them that he liked to look at. Like we'd plop them in front of him and he'd be like,
like what is that? Contrast. Very interesting.
But with that toy kit, in the first box there was a coffee cup that had the phrase the days are long but the years are short. And that is exactly a parallel experience to having a startup. Because actually the thing that Ilia was joking about earlier on the podcast of a beer getting humanoid, actually just being a vending machine with a autonomous cart, That was not a year ago, Ilia. That was like 2.5 years ago. We had that discussion.
Oh, there you go.
The startup time is like a black hole where I started my first startup when I was like 26 or so. And now I'm 35-ish, I think. I don't know. And I'm not really sure. And just like in my mental model of myself, I'm still like maybe 26 and a half. And
only 6 months has advanced in some sense.
Yeah.
And then
I
10
think,
years has gone by otherwise.
like the fact that having a kid is similar is useful in that like I can grok the joint mental model of it all, where there's so much happening all the time, but also not a lot.
Yeah, it's like a paradox for everything.
Like Polymath has achieved much less than I would have wanted to achieve in the years that we have, but like it's impossible to achieve what I want to achieve in any unit of time. But we've also done incredible, amazing amounts of things. We've gotten to work on some really cool programs. We've been on lots of different robots. We've seen really neat things. And I think the same thing's true with like kids, where like, you know, Fritz, my son, is now, we just moved from saying months to he's a year and a half. And
wow, it's a big transition.
Yeah. He can do lots of things, but like he still can't talk in sentences. So I don't know. Must be dumb. But yeah, it's cool. I don't know. Ilia's been a dad for way longer than I have.
Yeah, I have a 4-year-old daughter and a 1 3/4-year-old son.
1 3/4. That's great.
Yeah. I keep saying 1.5, and then I have to keep mentally correcting myself.
Yeah,
far beyond that now. Yeah, but the thing I want to highlight a lot, because my experience is a little bit different than Stefan. My daughter was already born when Stefan and I met and started discussing co-founding and doing this. And the thing I really want to highlight is the enormous role that your significant other, or spouse, or whoever plays in this, right? Like, I at the time was working at Amazon, relatively well paid, decent relative stability, decent program, was still working on robots, so still doing something I like. And I brought up this crazy idea of like, let's drop all of that, move to a startup. Hopefully it works. What do you think? And all credit to my wife. She incredibly was on board with this. She really wanted to understand the scope of the idea, meet my co-founder, try to understand if we're building something reasonable and what is it, is it sane? And yeah, so I think that's a huge chunk, right? Like that makes all of this possible. And her infinite patience to have me suddenly have a trip planned and needing to have her take care of 2 children and by herself. And then a day before that, the trip is no longer planned, but now there's a new trip at some other point. And now I have to go to this event, then I have to go to that event. And that introduces a lot of chaos. And so that is, the only thing that keeps us sane. I would say the only way that this would be harder would be to be a single parent and also run a startup. And I can't even imagine that.
I feel like
totally.
That is. I don't know how anyone is a single parent. That seems functionally impossible to me. Like not even have a startup. I just like take a shower. Like
yeah.
So we have superhuman levels of ability.
We have a puppy now, and the puppy's 2. You might have heard him bark a little earlier, but he is so much work, and I could not even imagine like single parenting a puppy. Like there's no way in hell I could do it, and I can only imagine a kid will be more for everything. Yeah. 1 or more kids. Oh my goodness.
But it's also really cool. It's great. It's really cool. It's really amazing. It's 10 out of 10 would do it again. Highly recommend.
2 thumbs up.
Yeah. I don't know.
5 stars.
Like there's annoying stuff, like he wakes up screaming bloody murder in the middle of the night. And there's disagreements on parenting strategies in the middle of the night because kid is screaming in the middle of the night.
Yeah, it's so cute.
And everyone's at their worst. And then there's like, when he went out for the day with his nanny, he kept on hugging me and my wife on his way out the door, and it's just like, oh my goodness.
Aww.
Or like last night, I'm giving him a bath, and like I figured this like kind of rubbery bottle, if I held it underwater, I could squeeze it, and like a burst of water would hit, and he like laughed incredibly loud. And like it's the coolest thing ever. It's pretty amazing. And yeah, I mean, I think it's just work and kids, it's a all the time, always. Like if instead we had done, how to not for cats, probably we could just be hanging out right now, either rich or unemployed. But it's a high level of intensity. And I mean, I think, honestly, before Ilia and I teamed up, when I was thinking about like startups and what I wanted to do, I desperately did not want to start another robotics company. I desperately I wanted to do some easy mode SaaS company. And the thing that I realized really quickly is that none of those things were exciting enough for me to want to work on a Saturday morning, instead of literally anything I could do on a Saturday morning. Even during peak COVID, it was I'd rather watch Netflix reruns than work on a trucking software company. And robotics has this incredible intensity that makes it incredibly compelling and rewarding. And I think life with a kid is a similar sort of uplift, where yes, it is really hard that they scream in the middle of the night. Yes, it is really hectic. Yes, it is like a puppy on steroids. However, it's this extra cool thing in day-to-day life. So I don't know. I'll just be tired until he's probably 8 or 10 or something. And until Polymath is in the billions of dollars a year revenue, and I can mostly be the founder who shows up and waves his hands in a black turtleneck every 6 months. But that's I feel like it's better living than the other way around.
I suspect that's true. Ilia, what do you think?
Well, I was just going to give a hint to the to yourself and to whoever may be listening on the waking up screaming and disagreements on parenting styles. The golden rule I read was that you have to make up your mind on how you're going to handle night crying during the day, and the rule is you cannot change your mind at night. There's no discussion. You cannot change it. Whatever you agreed to before is the plan. Period. That doesn't even enter your thoughts. And you have to be ready to reevaluate that during the day when you have a little bit more sleep every few weeks, because it will change pretty rapidly. But the plan is the plan. You don't discuss it. That saved a lot of chaos.
That is great.
Audra, have you and your partner,
my wife, Michelle,
your wife, have you and Michelle had your parents try to chime in not raising your puppy?
They haven't. So I mean, we're already getting parents talking, giving us advice all the time for things for the baby now. Puppy, they didn't really care. Our dog's pretty well trained. Okay, so I don't know. We generally impress with him.
We had a really useful experience when we just had a puppy pre having a kid. Yeah. Where we went to my mother-in-law's house, and my dog is great and lovely and charming, but neurotic and crazy and scared of stuff and this, that, or the other. And Cassie, my wife, and I would be arguing about some course of action for the dog in front of my mother-in-law, who then would take my side. And then Cassie felt teamed up on, and then I'd try to switch to her side, and there's just musical chairs of who's arguing, and it was just incredibly stressful, and no one liked it. And another piece of advice I'd give you, similar to Ilia's on night crying, is in front of anyone else, you guys agree.
Don't argue,
or just you're on the same. If you're arguing about what to do about night crying in front of someone else, and they chime in supporting one of you, you now support whoever is being who
attacked or ganged up on.
Yep.
Better just not to discuss it.
Yeah.
I think don't discuss it in front of anyone else for this kind of thing. Not an impromptu impassioned argument. There's
many wrong answers, but there's no right answer, realistically. So
that's hilarious. Yeah. One thing that you may laugh at with this is we moved to San Antonio, Texas. And when we ask people, or when people ask about how we chose it, we say it was the least bad of all the options. In a similar vein.
Yep.
Yes. Yeah.
Any other advice of kids that you can think of, or any other things to share? Maybe we'll go around once more. Stefan, anything for you?
I think on the kids side, I said all my stuff. Ilia's probably got more. Neat thing. So, if you're working on robots, we'd love to talk to you in general. We're So this approach that we're talking about mostly focusing on these big chunky industrial things that are obviously buildable, have put us in an interesting position where we're starting to have cash flow positive months.
Woo!
And that's
so exciting.
Yeah, like that is a big fundamental difference from the groups that I know who are saying like, hey, we need to raise $100 million to get a bunch of synthetic data, to then maybe get $500 million, to then maybe get $3 billion. And I think we're in a time where there's a lot of noise going on elsewhere about those sorts of approaches, and 99% of those companies won't exist in 3 years. But like the folks who can actually build a robot that actually creates real value are, half of us will be around. Like you can still screw up a startup when you have a product. But like
maybe a quarter of us will be around.
Most of the hype companies will die. Not 100%, but most.
Maybe not in 3 years.
Yeah.
Or they'll be acquired or something.
Yeah, but like many of them are too big to be acquired. There's not a lot of natural acquirers for a $10 billion pre-product humanoid robotics company.
Fair point.
Like there was when that company was worth $200 million and it was 2016 and interest rates were low and like cool. Like Google or whoever initially bought Boston Dynamics, like they did fine. But now at like the current valuations, that's just not feasible. So I think there's this incredible like slope of enlightenment that we're currently on for robotics around building things that are actually buildable and actually sellable for what can be built today. And I'd encourage more people to look at getting on that slope instead of the next hype cycle.
Oh yeah. Let's see. Yeah, I guess wrapping up, because I see that we are coming close to our end time. So Stefan, that sounds like what you want people to take away from this, which makes good sense. Ilia, what would you hope sticks out in people's heads from this whole interview?
Yeah, definitely Stefan's making the points on the business and robotics side. I'd say I gave kind of a talk last year at RoboBusiness on running a startup and running a robotics startup in particular. I think it's on our YouTube channel if people are interested. And what I ended up, that one was kind of two critical things. One, or let's add one more, but two to start. One is, even if you're building robots, you have to be humans. And I think that, like having a family, both myself and Stefan and many of our team members are younger and starting families. There's no blood from a stone that works well with complex technical things, like kind of crunch time that comes from gaming industry or heavy software dev does not work well, and is, in my mind, pretty clearly the less capital efficient way to do things over time. Like even for shareholder value, like it's almost always a net negative. So be humans while building robots is number one. And then the other thing is the lesson we keep having to learn over and over and is core to robots is you have to do less. Like
love it.
Do less, but do it better.
Love it.
Focused approach, like do that as much as you can. And I think both of those things are applicable almost equally to child rearing as they are building robots. Like they're very, very common skill sets of like, don't try to bring your kid to 30 different events. Like do 3, but do them really nicely.
What is child rearing if not building a really slow dev time robot?
Yeah. I think of that all the time, especially with a newborn. You're like, I keep giving this example. When my son was born, I noticed he would only smile if my face was oriented the same way his face was. Like he could only recognize faces in this orientation.
Wow.
And then, and that's apparently pretty common. And then like some amount of time, I forget exactly when, suddenly it snapped that like, even if my face was rotated this way, it was still a human face. And it was like an overnight change of like, rotation works now for vision. Like, good job. Yeah, it works. Right. And like, you could see these things turning on.
And I don't think he even had OTA enabled.
Yeah, no, nothing.
It's real impressive.
Just, reinforcement learning. I don't know. But yeah, so be humans and do less, but do it better.
Hell yeah.
Well, thank you so much for having us on today. It's a lot of fun.
Hell yeah. Well, thank you both. Do you want to plug your podcast real quick?
So you can learn more about us at polymathrobotics.com, and our podcast is automated.com or automated podcast.
I'll include the link.
It's at the bottom of the webpage.
It's called Automated. It's wherever you get your podcasts.
Okay, hell yeah. All right. Thank you both.
Thank you.
See you next time.
Bye, everyone.